All right, today, everybody, we are going to be talking about percent increase and decrease. This is a very big topic in the 7th grade curriculum in that we are dealing with proportionality in several different units. I want to say anywhere from 4 to 5 different units. We are dealing primarily with proportionality and how it works or threads its way through math for the 7th grade year. So if you look on the screen there, finding percent increase has to do with describing how amounts change. Percent change is going to be the amount of change over the original amount. The change may be an increase or decrease as it says. At first, we're going to be dealing with the increase, and it will describe how much a quantity increases in comparison to the original amount. So if we take a look at that example, we see that Amber is working at a job clearly. She started off by making, $8, and she's going to go up to $9.50. What is her percent increase? We can do that, as I said, by taking the amount of change. And when I talk about the amount of change, what I'm talking about is what the difference is between what she started with and what she will end with, and let's come up with a percentage that actually stands for. So I'm going to go over to my work. I know, and I'm going to take this out just a bit. I know that, again, my percent of change, I will sometimes refer to it as P.O.C, is your amount of change, that will be A.O.C, over the original amount, number, etc. Okay, so we know the WDIKs were that Amber pay was $8. Now it is $9.50. So once again, my AOC is going to equal $9.50 minus 8, which will be $1.50. Okay, that's how much her pay has changed. Okay, so at this point, again, I am going to use that dollar amount in my P.O.C formula. That's $1.50 over the original amount. Okay. Now I know that what I can do in order to not have to deal with such crazy numbers, I'm going to cross out my ending zeros. I can match those up in a division sentence to actually make my job a little bit easier. Okay. So what I'm going to do, I'm going to go ahead and divide this out. Remember, 850 divided by 8. Now, Mr. Moore, why did you drop off the decimal point? I know that there is an assumed decimal point after the 8. I can just use 8, okay? So at this point, what I'm going to do, I'm going to place my decimal. I don't have to move it over because there's no decimals there. Can I put 1 into 8 groups? No, I can't do that. Can I put 15 into 8 groups? Yes, I can do that one time. I can't pull anything else down but a 0. Okay, how many times can I put 70 into 8 parts? I can do that. How many times? We can do that 8 times. That becomes 64. I need to take my place out 4 places, and I'll tell you why in just a moment. Okay, this becomes 6. I'm going to bring my 0 down because I can't put 6 into 8 parts. That will now become 7. 56, and I'm running out of space. Okay, that becomes 0. And again, 8 times 5 will be 0. 40 here, 0. Sorry. Okay, so I'm going to zoom that in so you can see what I did there. That's 40 minus 40. That is 0. Okay, we all know that. Now, my decimal becomes 0.1875 in terms of a percent, and I want you to go look at my fractions, decimals, percent conversion video if you are confused. That will convert to 18.75%. Now, if I wanted to round this to the nearest tenth of a percent, what I need to do is I need to look, and that was tenth, T-E-N-T-H, tenth of a percent. I'm going to look at the number that's in the tenth place. That will be affected by the number next door, right next door. You know, if the number is 0 to 4, I'm going to keep it as is. If it is 5 to 9, I'm going to round up. So in this case, if I was going to round to the nearest tenth, that number would be 18.8%. But what if I wanted to round to the nearest percent? In this case, I'm going to look at all numbers before my decimal or to the left of my decimal. Again, I'm going to look next door. That number is a 7, so that means I'm going to go up. Rounded to the nearest tenth is this. To the nearest percent would be 19%. So in this case, Amber's pay was increased because, again, it went up. Okay, it went up. So her pay increased 19%. Okay. I'm going to turn this off so this looks a little bit better. Sorry, I should have had this off the whole time. All right, so 19% is what her pay, okay, increased. Now, I'm going to move on to, I'm going to write this as increase here. Now, decrease I'm going to do here, and I'm going to pull up another example. So hang on just a second. I'll go ahead and switch that over. Now, in this example, percent increase, as we know, was where we go up. Percent decrease, of course, is going to be where a quantity goes down. So David moved from a house that is 89 miles away from his workplace to a house that is only 51 miles away from his workplace. What is the percent decrease in the distance from his home to his workplace? Again, why would anybody work that far away from your house? I don't know, but let's go and figure out what his percent of change would be. Okay, moving back over to my work. The decrease said, what do I know? It said that David's distance from work was 89 miles. Now it is, I'm going to switch back over to make sure I have my numbers right. It was 89, now it's 51. Okay, miles away. So I'm going to use the exact same thing using my formula for P.O.C. or percent of change. That formula is amount of change or AOC over the original amount. Okay, so I'm going to go ahead and substitute this in. I know that he did work 89, now it's 51, and I'm going to put that over the original amount. Okay, so when we subtract that out, it becomes 38 over 89. 38 over 89. And in this case, I'm going to go ahead and divide this out. Now, I'm not going to divide this out longhand for you, but through the magic of YouTube, this comes out to be 0.4157. Converting that to a percentage, that is to the nearest tenth, okay? That becomes 41.57% is the raw number, and rounded to the nearest tenth, and I'm going to write that over here, to the nearest tenth. Remember, and I'm looking in this place here if I'm going to round to the nearest tenth, and then look right next door. That number tells me if I go up or down. 0 to 4, I stay as is. 5 to 9, I go up. That becomes 41.6% rounded to the nearest tenth. But what if it asked me to round to the nearest percent? And again, I'm going to look at the number that is to the left of that decimal place. This number right next door will tell me what I do. 0 to 4, keep it as is. 5 to 9, I go up. So to the nearest percent, it would be 42%. Now that is dependent upon what the question will ask. And on a quiz or a test, I might ask you to round to the nearest tenth or to the nearest percent. So again, at this point, what I would say is that David's distance from work decreased by 42% or 41.6% if I ask to the nearest tenth, okay? Let's go ahead and move along to a slightly different version of this problem, okay? Using percent of change, in some cases I'm going to be given the values from 1 to the next, or I might be given a percentage and I sort of have to work a little bit backwards, if that makes sense. Okay, so in this particular example, it says that the grizzly bear population in Yellowstone National Park in 1970 was about 270. Now, over the next 35 years, it increased by about 115%. What was the population in 2005? Now, as opposed to the example that I gave you earlier where you had two different values, maybe the value that was in 1970, then the value or the number that was in 2005, they're actually giving me a percentage. Okay, so what do I do with that? Let's take a look at my work. Now, if I know that it increased by 115%, I know that at 100%, the population is going to actually double. And at 115%, that's more than double. So step number one says that I would manipulate my original amount, okay? So my original amount went up by 115%, okay? So what I'm going to do is I'm going to multiply 270 by the decimal version of 115%. So again, this goes back to knowing how I convert from a percentage to a decimal. I assume that there is a decimal place there. In order to convert that to a decimal, I'm going to move my place over. And again, watch that video. If you're confused, I'm going to move it over to the left twice. Okay, that now becomes 1.15. Make that clear. I'm going to multiply by 1.15. And the reason that I want to do that is I want to figure out what amount is going to be 115% of 270. So I need to multiply that by 1.15. And again, through the magic of YouTube, I know that that amount is going to be, as per what it says here, I know that that amount is going to work out to be, let's see, that's 311. Okay, so when I multiply 270 by 1.15, that's going to give me the number 311 approximately. Okay, actually, it's going to give me 310.5. And the reason that I said 311 is because when I'm dealing with when I'm dealing with living things, it is very important that we have to interpret what the decimal actually means. Now, when I interpret what the decimal means, if I'm dealing with a living thing, can I have 310.5? Can I have a decimal part of a bear? Can I have a paw or a head or just a leg or a snout? No, I can't. So in that case, what I need to do is I'm going to approximate that to be 311 bears. Okay. Now, this amount that I just figured out represents the increase. Now, do I get rid of the original 270 bears? No, I just know that the population increased by that amount. So this was the original amount. This represents the increase. So what do I do to get the full population in 2005? You guessed it. I'm going to take this number, 270, plus my approximation, and I am going to come up with the new amount. And in this case, the new amount is going to be 581 bears. Okay. Now, I could do the exact same thing to figure that out. Okay, I could do the exact same thing to figure out a decrease. Now, in this particular case, it would make sense that there would be 115% decrease. The number would be something different. So, for instance, if I had, say, a sale and something went down by 30%, that's going to be a different question. But in this case, the number of bears will be 581 in that new year. Okay, 581 bears in 2005. Okay, now as always, if you have a question, please back this video up, watch it again, listen for my explanation, come to a tutorial either on Tuesday or Thursday, or ask me a question in class. And again, as always, I will see you tomorrow.